Hello and welcome to the IGCSE Physics course. This course is designed for the students preparing for the IGCSE Cambridge exams. The topics are arranged according to the syllabus. The course follows a structured pattern, making it easy for you to understand step by step without feeling overwhelmed. Additionally, you can review the videos anytime to reinforce your understanding. The first chapter we'll cover is quantities and units. Understanding quantities is crucial before discussing other physics topics because all formulas in physics use standard quantities and units. In this chapter, we'll explore what quantities and units are. Quantities are properties of objects that can be measured, like length, time, temperature, mass, and current. These measurements use standard units. All formulas in physics involve specific standard quantities and units. For example, length can be measured in meters or kilometers, time in seconds or minutes, and temperature in Kelvin or Celsius. These quantities are expressed with units. Quantities that can be measured numerically, such as length or time, are called physical quantities. However, properties like color, which can't be measured numerically, which means in numbers, are not considered physical quantities. Measurement involves comparing a quantity to a standard unit. For example, measuring length of a table involves comparing the table with the marks on a meter rule. Let's delve into units. Units are standard quantities used for measurement. For example, time is measured in seconds and mass is measured in kilograms. Using standard units avoids confusion and ensures consistency. Consider measuring the length of a room. If one person measures a length in meters and another in centimeters, they may report different values, leading to confusion. Scientists proposed standard units to be used universally to avoid this confusion, which they referred to as System International Units or SI units. Let's look at the standard units we are expected to know for IGCSE. The standard unit for length, which can be height, width, depth, is meter, symbol small m. The standard unit for time is second, symbol small s. The standard unit for mass is kilogram, symbol small kg. The standard unit for temperature is Kelvin, symbol capital K, though when temperature change is involved in calculation, we can use degree Celsius. And the standard unit for electric current is amperes, symbol capital A. We use standard units in the formulas. If different units are given in a question, they must be converted to the standard unit before calculations. We also use multipliers to handle very large or small quantities. For example, kilometers represent 1,000 meters, and milligrams represent 1,000th of a gram. Multipliers help us express quantities in more manageable terms. We attach multipliers as prefixes to the units to modify their value. Let's explore some common multipliers and their uses. The prefix kilos in kilometers and kilograms are examples of multipliers. Kilos means 1,000. So, 1 kilometer equals 1,000 meters, and 1 kilogram equals 1,000 grams. We also have smaller multipliers, like milli and micro, which represent 1,000th and 1 millionth, respectively. Note that the symbols, when they are capital letters or small letters, they mean different things, so this must be taken care of. Mega represents 1 million. So, 5 megawatts equals 5 million watts. Centi represents 100th and milli represents 1,000th. Giga represents 1 billion, so 5 gigahertz equals 5 billion hertz. Micro represents 1 millionth, used in measuring very small quantities. And nano means 1 billionth. These multipliers help us work with quantities across a wide range of scales. Understanding and using them correctly is crucial in physics. To summarize, understanding quantities and units is essential for accurate measurement and calculation in physics. Always use standard units and multipliers correctly. Make sure you used standard quantities in the formulas. That's all on quantities and units. Stay tuned for the next lesson, where we'll dive deeper into more exciting topics in physics. Thank you for joining this lesson. seoltutors.com